Okay, so welcome to this short videos of the section. Hold on, we got a little bit of cat interference right here. The other cat, not the one I played with. Well, welcome to the short part of the video. We did most of the section already in the first video. And what we have right here is just talking about some graphs. Okay, so I have a question for you. If two graphs are in the standard form, which one has a bigger A and which one has a bigger B? Now, of course, you might say, Jason, that's impossible to answer. You haven't given me a graph. Well, lo and behold, here's the graph right here. We got the blue graph, we got the orange graph. All right. So remember, A is the starting value, right? If I have Y is equal to A times B to the X, A is the starting value, B is the growth or the decay rate, right? So the starting value, that's the y-intercept. So which one has a bigger A is the same as saying which one is the bigger y-intercept. In this case, right, orange has the bigger y-intercept. Orange starts at a bigger value. Okay, we're going to say orange. Orange has the bigger A value. And specifically, we know the A value here, right? The A value for orange is 3. The A value for blue is 2. Okay, but notice that their growth rates are very different. Blue is growing pretty fast. Orange, it's growing super slowly, right? Blue is the current COVID infection curve. Orange is the COVID infection curve that we want, right? So blue has a much bigger B value. Blue has the bigger growth rate, B value, okay? All right, so that's what we think the answers are. Orange has a bigger starting, blue is a bigger growth rate. Let's check our answers. All right, so these are the two exponential functions. So again, orange has the bigger A. A is 3, A is 2. Okay, orange has the bigger A value, but look at the growth rate. Blue is a growth rate of 2, which is bigger than a growth rate of 1.2. Okay, so that's kind of one thing to do. Again, the textbook is really messy for these ones. Well, I'll show you. If you haven't seen it yet, I'll show you. Yeah, we'll show you at the end of it. But I want to do example 5 first. Okay, so consider this graph. And I'm going to plot it for you. I have to plot it while it's still hidden and you can't see anything. Right, so consider this graph right here. I'm going to ask you some questions about this graph. So specifically, my first question is, could this be the graph of y is equal to 3 times 2 to the x? So could this graph be this function? A value of 3, growth rate of 2. What? It certainly doesn't have an A value of 3, right? A value of 3 would say a starting value of 3. Here our starting values is 2. Starting value is 2, which means it can't be this function. Our answer is going to be no. It can't be this function. I haven't told you what it is, but it can't be this because our A value in our graph should be 2, whereas here the A value is 3. All right, for part B, could this be y is equal to, whoa, that's not right. Y is equal to 2 times 1/2 to the x. We have the right A value. That's good. We looked at our graph and we said, okay, A value is 2 right here. That's our y-intercept. It's in the standard form. But here, this isn't a growth rate anymore. This is a decay rate as we get cut in half every time we move to the right. This isn't getting cut in half every time we move to the right. It's getting multiplied by 3, I guess. Right, we have the 0.1, 6, so if we move over, we get multiplied by 3. It's not decaying at all. This is exponential growth right here. But it certainly can't be this function either. Right, we have a growth function, not a decay function. All right, so these are sort of introductory examples that I wanted to talk about to help you with the specific homework problems here. Because if you've looked at the homework problems, they're a little weird, okay? And I'm actually in the wrong section right now in this video. But if we look at the homework problems for this video, you can see more graphs. This is like what every teacher loathes to see, but every student I've seen wants to do. Just put it all on one graph, okay? So how are you supposed to match these graphs? You just look at each individual thing. Let's look at 13, right? Our initial value is 2, and we have a decay rate because it's 0.69, right? We kind of have to look at the candidates. It's decaying, so right off the bat, decaying means it has to either be green, orange, or blue, a blue. Okay. And so those are kind of our options, and we look at some other things, right? The initial value is 2. Some of them are initial values of 4. So 4 is going to be the one up here. 2 is going to be the one down there. So this has an initial value of 2, which means it can't possibly be green. The only thing that's decaying at 2 is orange and blue. And then you have to look at, well, what other ones are decaying at 2? Well, this one's at 2, and it's also decay rate. Which one's the bigger decay rate? This one's decaying faster. That means which one between orange and blue right here is decaying faster? Oranges. Orange is decaying faster. So this 13 has to be orange. 13 has to be B by that logic. So similarly, we could do the same thing for 14. It goes through 2, has to be one of these ones, and has a growth rate of 1.25. So it either has to be F or E. So the only things that go through here that are growing, exponential growth. And then you just look at the other one that has this situation, which will be 17, and say, okay, which one between 14 and 17, which one has a bigger growth rate? 14's growth rate's smaller. So between E or F, it should be F, because it has a smaller growth rate than E. F's growing not as fast. So that's the logic to approach this clump of problems, right? Then this other one was similar to our first example in this video, okay? The largest value of B is which one has the fastest growth rate? Which one's growing the fastest? Well, first off, right, green, orange, blue, these aren't even growing in the first place. These are all decaying. It has to be D, E, or F. Which one's growing fastest? It's going to be D, okay? For number 22, which graph has the smallest value for A? A is our starting value. You just say, okay, what y-intercept is the smallest? Oh, it's gray, F. All right, that's how you approach this sort of thing. All right, good luck. Let me know if you have questions.